So today we're going to discuss deferred annuities. We already talked about this before, no? So deferred annuity. We said that this is the type of annuity whose term does not begin until a specific time. So, for example, deferred after like 2 years or deferred after say 5 years, no? So it is formally described as an annuity whose term does not begin, so does not begin until the expiration of, so until the expiration of a specified time, or it can also be thought of as an annuity where the term starts at the end of the specified time, no? So the term starts, so that the term starts at the end of a specified time. So let's have an example. Okay, so here is the problem. If money is worth 5% compounded semi-annually, find the present value of a sequence of 12 semi-annual payments of 50 pesos each, the first of which is due at the end of 4.5 years. So the first payment is deferred after 4.5 years. So if we are to imagine our timeline, so if this is our timeline, this is 0, 1 semi-annual, right? 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are at the end of 4.5 years. So this is year 1, year 2, year 3, year 4, year 5. So that means that we are supposed to start payment at 4.5. So here. So start here, right? Then we're supposed to pay 12 semi-annual. So if we start here and then we count 12 more, no? So that would be 1, 2, 3, 4, 5, 6, 7, 8. So we stop here. This is the last payment. So that would be 11, 12, 13, 14, 15, 16, meaning 6 years, 7 years, 8, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 12 payments. So 8, 9, 10, it's 9, 10, 11, 12. So we stop or last payment. So last payment. So that would be 9 after 10 years. So all in all, you have how much? So this is 12 payments. So 12 payments, while this here is what we call, or what the book calls, fictitious payment. So there are 8. So there are 8 fictitious payments. Fictitious because to compute this, we're actually going to compute for the whole timeline, but we are going to subtract this because there's actually no payment here, no? So why does it have to be done this way? Because if you recall, when we derived the formula for finding either A or S, we used a geometric progression, right? So it should be a progression. So that's why it's done this way. So therefore, to solve for what are we going to solve here? Present. So we're supposed to solve for the present value, meaning A, right? So to solve for A, it's actually A, that is the entire timeline 20 minus the fictitious payment, which is which has 8 installment payments. So for the entire timeline 20, it would be maybe let's solve it here. So A is R A 20, right? Minus, you can actually put it here. So this is R A 20 minus R A fictitious, which is 8. I. Okay? So this will be equal to, we can actually factor out R. So R times 1 minus 1 point, what's our R? R is 5%, so I is 0.05 over 2 because this is semi-annual, so 0.025. So 0.025 raised to negative 20, right? Negative 20 all over 0.025 ay minus the fictitious payments, which will be 1 minus 1.025 raised to negative 8 all over 0.025, where R is, what is R? R is 50. So this will be 50 times, from my calculator, it's 15.5 58916 minus 7 point, so it's 7.137, which gives us 420.95. So the present value would be 420.95. Okay. Now, deferred annuity could be ordinary annuity or annuity due. It depends on how the problem is stated. But in this case, this is an ordinary annuity because it says the first payment is due at the end. Diba? So, ordinary if at the end of a period, annuity due if the payment is expected at the start of the payment period. Okay? So, that is deferred annuity. Now, let's have another example. So, okay. So, for this second problem, it says a man borrows 30,000 pesos with interest at the rate of 6% compounded semi-annually. He agrees to discharge his obligation by paying a sequence of 8 equal annual payments, semi-annual payments. The first being due at the end, so this is important, due at the end of 5.5 years. Meaning this is just an ordinary annuity. Find the semi-annual payment. So we're supposed to find how much will he pay every 6 months. In other words, what's this? Find R, right? This is finding R. Finding R. So, how do we treat 30,000? Since it is a loan, it means he already received it at the beginning. Meaning, it is a present value. Right? So, given is A, present value, is 30,000. So, present value. What else? R is 6%, meaning I is 0.06. This is semi-annual, so divide 2. So rate or interest is 0.03. What else? The term is what? N. N is 8 equal semi-annual. So term here is 4 years. 4 years, right? So what is this? 5.5 years. That's deferred, no? Meaning H. Did we use H? We did not use H in the previous problem. The fictitious payments is actually denoted by H. So we did not indicate. So this is H equals 8. No? So if H equals 8, what will be the N, the number of payments for the entire term? It would be H plus N, which in this case is 8 plus 12. That's why we have 20 here. Right? So, I skipped that part of the solution. So, it means we need to determine N and H. N and H. Right? So, here, what will be our H? H will be, since it's 5.5 years, then H should be 10, right? H is equal to 10. H equals 10. Therefore, N plus H is equal to 8 plus 10 equals 18. Equals 18, right? So here we are supposed to find R. Find R. So, solution, let's change the color to break the monotony. So, A, which is 30,000, would be what? A of the entire timeline. What's the entire timeline? N plus 8. In symbols, that is N plus 8 with I as interest minus the fictitious, which we denote with H sub I. Right? So, this is, oh no, this is RA. This is RI. RA. Right? So, we can factor out R. So, this is 1 minus N plus 8 is 20. So, 1.03 raised to negative 20. Ay, 18. Ano ba yan? N plus 8 is 18. So, to the negative 18 all over 0.03, is that right? Minus the fictitious payments, which is 1 minus 1.03 raised to N all over I, which is 0.03. Alright? Where A is 30,000. So, this is equal to 30,000. Therefore, R is equal to 30,000 all over this thing here, which is equal to, according to my calculator, it's 13.753513 minus the fictitious, which is 8.530228, which gives us an R equals what? 5,743.48. Okay. So, if you borrow 30,000 pesos with interest at 6% per annum compounded every 6 months, then if you pay after 5.5 years for a duration of 4 years, meaning 8 equal payments, right? You will be paying this much after 5.5 years for 4 years. 4 years more. Okay? So this is deferred annuity. Alright? So the next, which is the last topic, is value of an annuity on an arbitrary date. So value of an annuity on an on an arbitrary arbitrary date. So what is this? This means that given an annuity, what is the value of that same annuity in a specific date? No? Example, you have an annuity for, well, whatever. No? You can solve the A, you can also solve the S. No? So, and then you're asked, what is the value of that annuity, say, after 10 years or after 2 years? No? Or like 5 years before? No? So, arbitrary. You just want to know, for this particular amount of money, how much is it worth? No? How much is it worth after such and such time? So that is value of an annuity on an arbitrary date. So it is described as the value. So it is the value of all the annuity payments at any chosen, so at any chosen point in time. Okay. Or can also be described as the equivalent worth of the annuity at whatever date you choose. Okay? So, for a sample problem, okay, so a sequence of 5 payments of 50 pesos each will start with a payment at the end of 2.5 years. So it means this is a deferred annuity, right? Because you'll start paying after 2.5 years. If money is worth 8% compounded semi-annually, find the sum of the values of these payments, so the total annuity, at the end of, for example, 2 years lang, or after 4.5 years, or after 6 years. And also, find the actual present value of this particular annuity. So, to solve this kind of problems, what you can do is either to solve for A first. So either solve for A first or S. If you want to solve for A first, why do we want to solve for A or S first? Because we know how to solve for A and how to solve for S, no? So after determining A or S, you consider that amount as the principal and then compute as a compounded interest with time, whatever is time that is asked, no? So that's the basic concept in this particular topic. So for example, this problem, there's no more space for a solution, no? So let's solve it on the next page. So this is the problem. So first we look at the given. So what are the given here? Given. So obviously there's R, right? So there's R, which is where is it? 50 pesos. 50 pesos. So 50 pesos. N, which is this is deferred, no? So N is 5, meaning term is 2.5 years. Deferred. So when deferred, we need to determine H. So what is H? Maybe let's change the color. So H is what's after 2.5 years. So H would be 4, right? H would be 4. So 0, 1, 2, 3, 4, 5. So year 1, year 2, year 2.5. So you start paying, so 6, so 3, right? So you start paying at here, start payment. So if you look at the timeline, before you start paying, that is the fictitious payments, diba? Since you start here, then all the payments before that, payments in quotation, will be fictitious. Fictitious because you did not pay, because this is a deferred annuity. So therefore, H is what? 4. H is 4. H is 4. Right? So H is 4, N is 5. Therefore, N plus 8 is what? 9. 9. Right? So this is just an ordinary annuity. So ordinary, why is this ordinary? Because you start payments at the end. The end, diba? Annuity due is you start paying at the start. At the start of the payment period. But if you pay at the end of a payment period, then it's an ordinary annuity. So before we answer, so we are asked, so find out many things. So first, at the end of 2 years, end of 4.5 years. So B, C is at the end of 6 years, and D, actual present value, which is denoted by A. So when it's 2 years, this means N is 4, right? N is 4. 4.5 years, N is 4.5. 9? 9, diba? Semi-annual. At the end of 6 years, N is 12. And 12, actual. Actual is, this is a deferred annuity, so we have a different formula. So we want to solve D first. Diba? So, solution. Solution. Solve for A first. So, A for a deferred annuity is, what was it? R R A N plus H I minus R A fictitious H I. Ano na? So therefore, we factor out R. We have 1 minus, maybe let's use first the, so A, N plus H is 9, I is point, we forgot R. R is 8%, therefore I is 0.08 over 2 is 0.04. So this is 0.04 minus A, fictitious is 4 at 0.04. Alright? So, wow. R is 50 times 1 minus 1.04 raised to negative 9 raised to 9. So, negative 9 over 0.04 minus 1 minus 1.04 raised to negative 4 over 0.04, which is equal to 50 times, according to my calculator, 7.4353 minus 3.629,895, which gives us 190.27. So this is A. So what did we say? We said that for the rest of the arbitrary time, we will treat this as a compound interest problem, no? So what's compound interest? Let's separate computation. So let's answer now. For A, what is the value after 2 years? So letter A. So first, let's recall the formula. Future value is equal to present value times 1 plus R raised to N. Right? I 1 plus I raised to N. So, letter A, we are asked to solve for the future value after 2 years. It means N is 4. So, we have P times 1 plus I to the 4th, where P is the present value 190.27 times 1.04 raised to 4, which gives us 229.59 daw. So, 229.59. The next question is to find F after 4.5 years. So 4.5 years would be n equals 9. Let's just put it as a subscript. So 190.27 times 1.04 raised to 9. From my calculator, it says 270.82. And the last problem is, let's use another color. Letter C, find the future value after 6 years. So, 6 years. So, this is P1 plus I to the 12. Right? After 6 years, your n there is 12. So, we have 190.27 times 1.04 raised to 12 is 304.63. So, yeah, this is what? This is a value of an annuity on an arbitrary date. Our arbitrary dates here are after 2 years, after 4.5 years, after 6 years, and so on and so forth. No? Okay. So, let's have one more problem. No? I think I'll have it in the next video. I'll stop here because it's already 40 minutes.